Hello, this is Mr. Kent of MrKent.com, and in my last video, which I just produced yesterday, I explained how I had cleaned a motor in my little sport cub. I had cleaned the motor with gasoline. Well, the report is I took it out this morning and flew it, and that motor is so quiet. I have never heard that motor be so quiet. So you might want to just pull the motor out of your little sport cub and wash it out. Now the problem is, let me find it here. Okay. The problem with this plane is it has a brush motor. Okay. You notice how it turns real smooth. Didn't do this a while back, but I fixed it, so it turns really smooth. Now that little motor has little tiny brushes, and I'm going to explain it here more in detail in a minute. But that has brushes in it. That's not a brushless motor. Now, a brushless motor, let me see, where did I lay it? Here it is, okay? A brushless motor, like you find in your Bebop, when you turn the propeller on the brushless motor, you see how it wants to, like it's got pistons and cylinders, and it wants to center on something. That's what I like to pretend. But it still spins, but it wants to lock up. And that's because there's magnets in there attracting other magnets. So that's how you can tell, if you don't know, that's how you can tell whether it's a brushless motor. Also, my other plane that I have, which has a brushless motor in it, you notice how it does the same thing. It flips like this. And one thing about brushless motors, get the front off, there's the motor right there. And brushless motors are generally smaller than a brush motor, and they're lighter and just a much better motor, and that's why everybody's using them nowadays. Long ago, when I was, well, not long ago, just not too many years ago, we'll go back, we'll say 20 years, they didn't have brushless motors for DC applications. They had brushless motors for AC, and I'll explain that too. But what I'm going to do is I'm going to show you the difference between a brush motor and a brushless motor, and we'll talk about that. And then if you have any questions afterwards, you can comment or something like that. So let's take a look at my little drawing that I made and see what the difference is between a brush motor and a brushless motor. All right, let's get started with looking at this little drawing that I made. And if you remember from grade school, maybe your teacher gave you some instruction on this. But if we go to this first little illustration here, anytime a current flows, it always flows from negative to positive. Anytime a current flows through a wire, it generates a magnetic field around that wire. You can't see it, but it's there. And so it's not very strong, but there's a magnetic field. When the power is removed, the magnetic field collapses and it's not there anymore. But that's what causes magnetism. Now, if we go over here to this drawing here, and if you did this experiment in school, or you can do this at home, just take some wire and wrap it around an iron nail or steel work. You wrap it around there, hook it up to a battery, and so as the current flows through this wire from negative to positive, then it generates a magnetic field, and it reproduces and reproduces and reproduces and reproduces, and pretty soon as it's cutting through the iron nail, well, it ends up then causing the nail to become magnetized. And you can actually do this and pick up little pieces of metal and stuff like that with that. So that's the principle on which all of these motors work, is running current through a wire and creating a magnetic field and then coiling it many, 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 many times around an iron core. So let's go over here. I didn't label these. I should have. This is a brush motor, and this is a brushless motor. So we'll start with the brush motor because they've been around for a long time. In a brush motor, when this is the part that turns, okay, and the shaft and everything like that. In a brush motor, you have these brushes. They call them brushes. They're usually made out of some carbon material. that's not going to wear out, and it rubs gently. They have springs against them, and it rubs gently to against this rotating commutator, okay? And this would be the shaft of the motor here, all right? So what happens then is as these contacts on the commutator come around and they make contact with the brushes, and now you have current flowing from here through the brush and in a coil that goes out the other side, generating a magnetic field, okay? Now, also in an electric motor, the stator, or the part that's not turning on the outside, there are more than one. I just made it real simple. I just put one magnet, but they have a bunch of these and a bunch of these around the circle. So when this comes into contact, it generates a magnetic field, and this is a piece of iron or a magnet, and so it draws it over here. Now it's turned off because it lost contact, but now you got your motor turning, okay? And so it starts to turn and it comes around, and then pretty soon the commutator connects with the brushes again, and this magnet is drawn to this steel or another magnet, and it sucks it over, and that's how a brush motor works. And like if I had drawn a whole bunch of these, somewhere on the opposite side of this one, there'd be a chunk of steel. And then when these make contact, this is drawn over there. So it just keeps going around and around and around as long as there's electricity connected. And and they've got it designed so that when these make contact, this is close to this, and it will draw it and start it to turn. Now that's how a brush motor works. The disadvantage of a brush motor is they have little springs pushing these against the commutator or the center part, and those springs are going to slow down the efficiency of the motor, and the brushes also wear out or chip off, and that may have been, in my last video, that may have been what happened to the first motor because it just quit working. And then the second motor I got, when it started slowing down, I opened up the fuselage of the plane, I noticed there was little chunks of black stuff laying around. And of course, that gave me the idea to clean it with gasoline. So that's how a brush motor works. And until, not too many years ago, that's all you had when you were running DC. Now let's go over and take a look at what would be similar to the old-fashioned, well, for instance, you've got a motor like this if you have an electric saw, or if you have anything that has what's called a synchronous motor. And we've had synchronous motors for a long time, but they run off of the 60-cycle voltage that comes into the house. And so that what happens is that motor then can only run at one speed, but we won't get into that. Not too long ago, when computers came out and people started using ideas for creating programs in a computer, that's when we finally got the brushless motors that we use in our airplanes and so forth. So what we have here is we have a circuit with a battery that comes around here, and a coil here, and the current goes back in here. The only thing is this, it doesn't flow all the time. It only flows when you're controlling your sticks on your drone or on your airplane, and that signal is sent through the transmitter out up to the receiver on the plane or the drone, and it's sent over to the that's electronic speed control. It's just a computer is all it is. And so what happens is this is a piece of magnet like we have over here, all right? And this here is this guy right here is an electromagnet, okay? And he only gets magnetized when the electronic speed control says you're supposed to be magnetized. So if, for instance, and then what happens when he gets magnetized, well, then he sucks this magnet over to himself, and then, of course, the computer says, now stop, don't pull him anymore. So then this coasts around, gets all the way around again, and gets back and comes around again, And now, by the way, there's a lot of these. That's why when you turn that prop around, you feel it going between a lot of them. There's a lot of these, and there's a lot of these. But I'm just keeping it simple with just one, okay? So when you when you open up the throttle on your drone or your airplane, well, then this thing starts pulsing, and of course there's a bunch of them around there. But what it does is it says, okay, give me some magnetism here. So then that draws this piece of iron over, and the magnet and the iron are pulled together. But then ESC says stop, and so this coasts around. And as it goes around, it's going. This is telling the different ones in the different places around the circle. Believe it or not, it's telling different ones when to pulse and when to not. Okay, so and the way the old days when we would control speed, we would just we would control the current. That like we'd have a little device right here that would be like a volume control, and if we had a little bit of current, we had a little tiny bit of magnetism, and so it didn't draw it very fast. But if we turned the speed up, then we had a lot of current, and so when that thing connected, well, then it was a lot stronger magnetic field, and it would pull it over there. That's how that worked. On this, the way it works is so that if you want it to go slow, then the ESC says, okay, now pulse this thing here and draw the magnet. So now it pulses it and it draws it, and it didn't have a long time to pulse, so it's going to run slower. When you want to go fast, well, then this is coming around here, and this pulses sooner. It pulses this one sooner, and so now it pulls it a longer time, and so it gets to pick up more speed before this shuts off. So that's this all computerized, and it just takes it and pulls it around. Now, here's the thing. This takes much less mechanical parts than this, so you don't have anything rubbing against you. But the electronics part is the thing that we never had in the past. Now we've got that, and it's just a computer, but they call it an electronic speed control because the difference between fast and slow is when he decides to pulse. If he pulses when it's here, then it doesn't get a very long pulse, and so it doesn't go around very fast. But if it comes around and he pulses here, it's going to stay pulsed until he gets down here, and then it's going to turn off, and so then it's going to make it go faster because the pulse was longer. Anyway, I hope that makes it clear. And if you don't understand, if you have more questions or something, I'll try to answer them. I am not an expert on this. In fact, it's new to me like it is to everybody else over the past 20 years or so. Actually, it's not been 20. It's not even been that long. But originally, a brushless motor cost a lot of money. And then they started manufacturing them in China, and the price went way down. And so it doesn't cost too much to get an airplane now that has brushless motors in it. Whereas, 15 years ago, if you wanted a brushless motor, you had to pay a lot more money. And so I didn't buy any back then because I didn't have the money. Anyway, another thing, this will wear out, and this will probably never wear out, although if you're not careful, you can burn up your ESC. So you don't want to leave the battery on in your drone or your plane for a long time because that is hard on the ESC. Okay, well, anyway, I hope this broke my motor. I hope that answers questions. If not, well, you can put comments in, and I'll try to answer your questions for you. But anyway, that's how a brushless motor works compared to a brush motor. I hope you understand because I'm not the world's greatest instructor. But thanks for watching, and God bless you.